and we were guided by Dr. Daniel Katz and Ben Clifford throughout the process. So now we'd really like to talk about the purpose and the objectives behind our project.
So when we began to work with Parcel and our workflow, we were intrigued by the idea of balancing the workers and the cost of a function to provide an efficient algorithm. So then we came to the research question. So how should workers and costs be balanced to manage the efficiency and speed of a specific workflow? And however, eventually, as we continued to research, we realized that different developers have different goals, and we need to reconsider the idea of optimal, as different programmers aim for efficiency while others care more about speed in terms of their programming. So we wanted to better understand how the use of time and resources can be managed for different workflows and how speed and cost were related in a parallel programming structure.
So our solution to this was EEPS, or the Efficiency Evaluator for Parallel Scripting. This program determines the costs associated with running a parcel workflow with respect to the time it takes. It outputs this efficiency data in a charted graphical form. Users can analyze this data and determine the most optimal number of cores for their own workflow based on their priorities and limitations, as we explained earlier.
So now we'd like to present the graphs we got from testing EEPS on our specific workflow. So like for caution, so when you run this on your own workflow with a different system, your graph may look completely different. And we ran ours on a 16 core system, and our workflow had a very little dependency structure. So you can see more changes as the amount of workers were included. And so far in our graph, we displayed the cost and the times and how they were affected in terms of how the workers were changed. And for us, we believe that the best measurement for cost would be the amount of cores being utilized times the amount of time it took to compile. So we developed the unit called core seconds as a unit of time, a unit of cost, and we also recorded the time. So using this graph, a programmer or whoever is using our program EEPS.py can understand how their program is efficient in the amount of workers. And again, your graph may look completely different depending on your workflow. And eventually it should level off because no program can run more quickly than the longest chain of dependent calculations. So like the critical path, and since the calculations that depend on prior calculations, it has to be executed in a specific order. So it will level off eventually, and maybe it may even increase as the cost increases.
So similarly, this graph shows the cost of the number of cores and the time it takes to run our sample workflow with each core. And as Ved explained, this is very particular to our sample workflow, and it'll be radically different based on your specific parcel workflow. So the numbers shown there represent the number of cores, and the cost and time are charted at the axes, and they really give the user a good idea of what the trade-offs will be for their select number of cores. So towards the end, the law of diminishing returns is really visible as it shows like really little improvement with regards to time as the cost rises. And this can really prove to be really useful for parcel workflow users, so they can find the quickest running and the most efficient number of cores without overspending.
So now our guide on how to use EEPS in your own workflow and your own research. So we developed a 3-step process currently. So you create your own workflow, and then with that workflow code, you input that into EEPS.py based on what our documentation says. So we have a specific lines of code that you should replace with your own individual workflow. And then you can run it with a 16-core system or whatever cores you choose, or even a cloud system. And then you can view the charted information. And with the charted information based on your own needs, you can choose the couple values that you want to test. And using single cpw.test.py, you can test those values to understand how those cores or those workers will impact the efficiency and the cost of your program. So we also, there are some future improvements with our program. So right now, the way we have our code set up is that you develop your own workflow and then you type that into our program. But in the future, we want to modularize our program where you could create your own Python file with your apps, and then we could run that and like a plug and play format for our program. And we also plan on implementing the monitoring.db functionality. So when we have a parcel workflow, you can use the monitoring.db, and we plan on using that data to better display information. And with the information, we plan on having more informational graphs that enables the user to input specific requirements. So right now we put every single value on, we put everything they need, but I think it'll be more useful for the user to tell us what they're looking for. So if they want it to be between these speed constraints or these cost constraints, our program can better display those and output ideal workers or course for their specific workflow and their necessities.
So that's all we have today. And we'd really like to thank Ben Clifford, who really was a guiding hand for us throughout the process, and Dr. Daniel Katz for giving us this opportunity. Now, we have a couple links posted as well attached to this. This is our GitHub repository, and this is more information if you'd like to learn more, and it's posted on the Parcel blog as an article.
Yeah, and thank you guys so much for letting us speak today, and I hope you guys had a great day.
Yeah, thank you guys for both presenting there. That's awesome. Do we have any questions?
Yeah, I have a question. So my question is, so you entered your workflow into the EEPS system, and then it spits out like something that I'm guessing you just throw into the parcel config, correct?
Yeah.
Is there ever a case, and you could say no, I was just very curious, if there's, one part of the parcel workflow that is obviously better utilized or could be better utilized by one parcel config, and then a separate part of the workflow that's better utilized by like a different number of cores, for example.
Oh, I see what you're saying. So like in the beginning of the first half of the execution, you might just want to have 3 cores, and then later on use more. Yeah, that's actually really interesting to think about. The way we have our structure currently, it's for the overall workflow, so we display it based on that. But with our, I see what you're saying. That would be really interesting to further research on, with how you could see the optimal amount of workers for like a section of code. Because if the first third of the program only requires 3, and then later on you need 6, you don't need 6 throughout. It would be better if you could utilize 3 and then 6. So that would be cool to research and see if we can implement that anyway in EEPS.py.
Cool. I was wondering if you could, would it be possible to extend it with other cost metrics like plug-in IO usage as opposed to CPU utilization?
Could you repeat it? I couldn't hear you.
Oh, sorry, my network's a bit shoddy. But yeah, I was wondering if you could modify the cost metric. So currently you've got your core hours being used.
Yeah.
I wonder, would you be able to like put in memory utilization or the amount of IO that it's plugging in, like just switch that out with something else and then plot other metrics?
Yeah, I think initially when we were developing it, we did try to stick with something a little bit more simpler because we were really getting used to how it all worked. But yeah, those were definitely other things, other cost metrics and other factors that would be used to really evaluate the program and its efficiency. We were really going to look forward into that in the future.
Yeah, and I think as we implement database like the monitoring.db, we'll have more information to compute new units that will better help us understand the cost. So right now, what we had with the cost per seconds was our best unit for efficiency and cost. But when we begin to use monitoring.db, we can venture on to using new units for the y-axis for that function.
Cool. Any other questions, or should we hand it back to Kyle to close out?
Can I ask a quick one?
Mm-hmm.
Quick one, yeah. I'm wondering, and I might have missed this, does this update that configuration as a continuous process within a parcel run, or is it more of an experiment that you would run prior to fully deploying a workload?
So in the beginning, when we decided to start this research, we wanted to try to do it where it would figure it out and then run the workflow based on that. But then we decided to rather do it as an experimental run where you run your workflow and you get the data. And based on that, then you use that config for your individual tests. But yeah, this is just an experimental workflow for you to decide your own values and then you run it.
Cool. Thanks, guys. This is really cool work.
Thank you.
Yeah, awesome. All right,
Thank
take
you,
it away, Carl.
Okay, well, yeah, first, Ananth and Ved, that's amazing. The work you guys did in such a short amount of time at such a young age, that's really, really impressive. Obviously, you guys have got a bright future, and hopefully we'll see you at a future Parcel Fest. I think this is the first time we've had to schedule a talk around the school day. So thank you guys for finishing a full day and then coming and joining us at the end of the day. And apologies, of course, to scheduling you very last, because it's always one of the hardest slots to present when people are starting to fade after a couple of days of talks. So unbelievable work.